Hello and welcome back once again to the SweMove Fullstack tutorial. In this tutorial we're going to be going over what is an indexer, how to think about using an indexer, why Swe requires a different approach to indexers than other chains, and then we're going to be implementing our own quasi-indexer using an AWS Lambda and also deploying to testnet. And we're also going to look at Shinami and their gas station feature, which is going to make it really nice UX experience for your users. So to start off, we left off, right, we created SwePlace, and right now I'm on the version that's uploaded on my website, but we have a little bit of a problem, and that problem is that if you don't have a wallet, so I just I disabled my Swe wallet temporarily using Chrome. If we don't have a wallet installed, it asks us to connect a wallet. And this is a really bad user experience because compared to a lot of other dApps, if you don't have a wallet installed, for example, when you go to Uniswap, you're not going to be able to make a trade, but you're going to be able to see like what are the prices, what are all the different coins that you can do, right? There's something that you can interact with that's like tangible before you even have a wallet installed. And this is really important because if I don't know what SwePlace is and I get linked to this website, I want to be able to see like all the different things that people are building. I want to be able to see what I'm doing before I trust this website enough to either just connect it or even to install a wallet if I don't have one installed. So the point of an indexer specifically for us is to be able to get us to a point where we can just send somebody to the link to this website and then they can go and they can view and they can see all the things that people are placing and see all the pixels without them to even know what Swe is. And then they have the option of installing a wallet and then placing their own pixels. So the reason why we're doing it the way that we're doing it right now is because recall that when we're getting the pixel state, when we're seeing what the board is, the way that we actually get that data is we make an RPC call, and that RPC call is getObject, and we supply the 4 quadrant object IDs, and then that RPC will give us back like what it believes the current board state to be based on what's available on chain. And the easiest way to get that set up is if you just require users to have a wallet when they're viewing the board. And the reason why is because every single wallet ships with its own RPC, because when you make a transaction with the wallet needs to send that transaction to its own RPC, and it needs to guarantee that it has an RPC. So in general, you can assume that if the user has a wallet, you can use that RPC associated with that wallet, and it comes at no cost to you. And typically, and I'm pretty sure in nearly 99% of wallets, the use of the RPC is totally free to the end user as well. So this is just a quick and dirty method, but again, at least a bad UX. You have to have a wallet installed or it doesn't work. And also, it's the most decentralized way of doing things, because if you do everything through the RPC and the RPC is provided by the user, then you never have to maintain any kind of off-chain server. And if you never have to maintain an off-chain server, you can just put your front end on IPFS and then have it displayable or distributable in a persistent manner, and there's never going to have to be like one kind of central party that maintains things. If you step out from the project will still work 10 years from now, as long as IPFS and all these other things still work. So this is another way of doing things. This is another quick and dirty method. Is you can actually just hard code the fullnode.swe.io or whatever the URL is directly in the front end, and instead of using the RPC that the wallet provides you, you just have some kind of constant public RPC that you're gonna get the front end to send requests to. And I would actually recommend doing this right now if you're just trying to do like a small test project and you really don't care about like performance, and you're okay with you don't need it to last for a long time. This is actually probably just the easiest thing to do. If your application can get away with getting by from data only by like getObject calls, this actually isn't that bad of an idea. But when your ecosystem matures, if you actually plan on gaining users, it's really not a very good idea, because the public RPCs, for one, they're somewhat high latency, they're not very fast, and it's possible that you're going to get rate limited, so it might not work forever. So it really is recommended to, like, if you want a more serious project and you want a better UI or better UX for your users, it makes a lot more sense to pay for a private full node. So you may have just noticed how I just changed my slide, and instead of can't do object aggregations, I changed it to you can't do all object aggregations. And the reason why is because when I was recording this video, there was an RPC call that I wasn't aware of, and so I was under the impression that you could only get one specific object by object ID. You couldn't do anything else on the RPC. But actually, we have this other method, the SWEX get on objects method, that allows you to do a little bit more querying, which doesn't let you do all object aggregation. So the advice that the rest of this video is still valid. Like when you're hard coding the RPC into the front end, you can do things like like let's say that you can assume that one person only has like a certain list of objects, and it's okay to paginate through those objects. Then you can get away with doing the RPC. But like let's say for certain things like, oh, I have a token list and I want to maintain a list of who are the biggest the biggest token holders. Like in theory, actually, yeah, you can do that on the front end, but it's going to be super unperformant because you're going to have to paginate through, like if it's a SWE, if you want to find the biggest, SWE token holders without maintaining some state and like caching that, it's going to get super expensive. It might not even be doable because it's possible that these objects, if there's enough activity, that these objects are going to update faster than you can paginate with one worker thread. So let's actually take a look right now at the specific RPC, and I really recommend going through these docs. But so this SWEX get on objects. Another nuance is that on the RPC we have SWEX and we have SWE. I believe SWEX stands for SWE extended. And I'm pretty sure the difference between SWEX and SWE is that this requires, this is available on all SWE nodes, but this requires a full node like backend. This can be run on, I believe, a light client, but this needs something more full. So it's possible also that as the chain matures, we're no longer going to have like public extended full nodes, or the full nodes, or public extended full nodes are going to be super rate limited and like kind of unusable. So just something to be aware of. But what this get on object does is it gives you like the list of objects owned by an address. So like this lets you do some aggregations, right? Again, not all. We're going to talk about what if you want to do more complicated aggregations. We're going to talk about that later. But this is something to know. Definitely good to know. It's going to let you do simple aggregations and simple listing of objects. Another thing that you can do is, let's say that you want to keep it very decentralized, and you don't want to maintain some kind of server. What you can do is, if you need to do aggregations, you can maintain some kind of like registry on chain. So you'd have, like, let's say again we're going back to this card game example. Like, let's say that you represent one account as an object on chain that an address owns. You could require that as part of the move function that creates that account, it also adds that account object by like address somewhere into some mutably shared like vector, mutably shared set. And so that way, that whenever you want to say like, oh, I want to list all of my users, then you can do a move call, or you can look up the registry by object ID, and then it'll all exist as fields on that shared object. But the problem is that this is a pain to architect, and it's not always possible for things like tokens. Like maybe you could do it with coin, but you'd probably have to wrap it in some way, and it would definitely be very annoying. It's not really possible, as a first-class experience. And it also means that because you're using these shared objects everywhere, the transactions are going to be higher latency, right? Because remember that the trade-off we have is that shared objects are like globally consistent, but they're also, and like anybody can use them in transactions, shared objects, but they're lower latency because you have to share them across the entire network. The validators have to send what is the latest copy that I have of this across the entire network. And they're also more expensive in terms of gas because you're going to have to do all of this, like maintaining data and keep an extra, database on chain. Now in SWE, I wouldn't worry too much about gas prices, but definitely like a code, it's definitely a concern with like the amount of work that you're going to have to do in terms of contracts, and you probably do care about higher latency transactions. So the way that we're going to do it, and this is what we're going to implement later with the Lambda, is where we have a private RPC. So this is going to be an RPC that we rent or pay for access to. Specifically, we're going to use Shinami, which is a node provider on SWE. And that gets you a lot more performant RPC compared to the public free ones. Because it's private, right, you get better quality. And because we're putting it behind an endpoint, we have the option of putting like a cache or a rate limiting behind that endpoint. Note that it's possible you could put that private RPC URL and hard code it in your front end, and I actually think there are some SWE applications that do it like that right now. But the problem is that once you make that RPC endpoint public, the private RPC endpoint public, then anybody can go ahead and use it for any purpose. And that's going to get expensive. Like I could hijack your RPC and use it for free and not have to pay anything and get a performance for while you're racking up the bill, right? And you don't want people to have that. It's generally best practice, and I've confirmed with the people behind Shinami that you want to hide that RPC behind some kind of endpoint so that the whole world doesn't have access to it. It also allows for persistent historical data. So if you're calling the RPC on some server, that means that you can store data on that server that lasts across like calls. And this is like probably the recommended way of doing like historical data, right? So you have some kind of DeFi protocol and you want to keep track of, what is a historical price. Well, at the endpoint, like whenever you're, like let's say that your users have some kind of like get current price or get historical prices. Well, what that's going to do is it's going to make the RPC call to get the current price and then store it in a database, and then every single time you make the call, it adds it to the past database and returns like returns all of the data and returns that time series data that was already in the database. And that's not really possible to do unless you want to keep track of that on chain, which is pretty annoying and hard to do. If you want to keep track of some data that doesn't currently exist on chain but existed on chain in the past, this makes a lot more sense to do. The downside is that you do have to maintain servers, and we're going to use something called AWS Lambda, which you could also this exists on other cloud providers, like Azure has, I think, like Google Cloud Functions, Cloudflare has Cloudflare Workers. So whatever like MongoDB has something else. So whatever cloud provider you want to use, there's going to be an alternative to this. But what a Lambda is it's just a small script that you can run. So that you have like it runs on their execution engine and then it gives it its own endpoint, but you don't have to maintain like a whole Ubuntu server and do all that kind of maintenance. And the advantage is that they're very close to free. So for example, on AWS, you get 1 million calls to this Lambda for free, and then it's super cheap after that. So this is a really good option. Like if you're a startup and you don't want to spend the time on maintaining servers, and like let's say you don't know if people are actually going to use this application. Well, if nobody uses the app, you're not going to get any calls, and then it's actually just free. So it's a little bit cheaper if you're like a student or a startup, as opposed to like renting a server from a VPS like cloud provider. But it is a little bit harder to set up. The downside is that if you're only using an RPC, aggregations can be a little bit difficult, and this is again because the RPC doesn't give you the best tools of like listing out all of the objects that you don't own. And if you want to do something with aggregations, like let's say you have an application where you really want to maintain a list of like who are the top 10 token holders across some coin, then that's when you're going to want to use something like a full chain indexer. What a full chain indexer is it's a server that keeps itself synced with a full node. And what that means is that it's going to make sure that it has all of the latest data, and it's just another node that you have access to the internal state to. So you like for example, instead of being behind this opaque like RPC where you're limited by like what is the API reference and what methods can you call, you get access to the actual database of what's going on behind the scenes, like what is the entire node state, and that's what's going to let you do things like list what are all of the objects owned by anybody in the entire SWE ecosystem of a particular type, and you can do those more kinds of advanced queries like that. The problem with a full chain indexer is that it's a lot of work. It's really hard to do, and it's also kind of expensive because there's a lot of data going on when it comes to the blockchain. You have to send a ton of data, and ingress is expensive. I was talking to the people behind Huracan, and they were saying it was about a few $1,000s to maintain like a fully sharded node. And the problem is that I don't believe, at least to the best of my knowledge, there isn't any managed service of this. So you can't, like for example with Shinami, is that I can pay them to maintain that full node that I have private RPC access to. But I don't think Shinami at the moment offers any kind of like indexer service. I don't think the people at Huracan intend to provide one, although I could be wrong. So ideally, in an ideal world, it'd be super simple as just buying this and renting this from somebody, but you can't do that because this would make it an easier. And personally, I think this is like a very desired product, or at least I would personally really desire this product on Sui. So it is the best for aggregations because you get access to the underlying database, and it is best for like serious and well-funded teams to provide the best possible UX. But again, it's expensive and probably not what you want to do if you're like a student or you're just doing something for a hackathon. So in order to get started with an AWS Lambda, we're going to first make sure that we have a valid AWS account, and you can figure that out how to get that set up pretty easy. It's probably going to ask you to put in a credit card. That's okay. We're not going to be spending any money. And also keep in mind that the AWS Lambda is going to show up differently on depending on which region you are. Like the ones that you have in for example, US East 2 are different than the ones you have in US East 1. So I prefer US East 1. I tend to make sure that I'm using this AWS region. We're going to stick with that. So we're going to get set up with with our credentials that we can put into the AWS CLI. So we're going to go to IAM in this dashboard, and we're going to go click on users, create user. We're going to call it AWS CLI. Hit next. We're going to add users to group, but we don't have any, since it's a new account, we don't have any groups set up. We're going to create a new group, call it admin. Just set it only with administrator access. In theory, you want to make this a little bit more tight than just administrator access. This is going to let this user group do anything with our AWS account, and you'd probably want to restrict it to only being able to do stuff with like Lambda and S3. But that's more in depth than I really want to get into. Again, this isn't a tutorial about how to do everything with AWS, and if you're doing this in production, you definitely want to look at all the settings I'm doing in more depth. But this is good enough for like a hackathon, or this is good enough to get us started, and then later down the line we can go and make sure it's all super nailed down. So we're going to create that user group. We're going to add user to group, select that, hit next. Everything looks good, and then we're going to create the user. Then in this page, we're going to click on the username, we're going to click on security credentials, and then we're going to do create access key, and we're going to use this for local code. Again, they recommend alternatives. We're going to install this too, and you definitely want to, if you're doing this in production, you definitely want to examine this a little bit more closely. But again, this is good enough for now. We don't care about the tag. So now we have this access key and this secret access key. Make sure to keep this private, because if somebody has it, then they can assume this is your password basically, and they're going to be able to rack up a huge AWS bill, and we don't want that. So now going back to the terminal, I have these two CLIs on my machine. This AWS and SAM, which stands for serverless application model CLI. These are pretty easy to install. I'm not gonna go in depth. I'll link some documentation. Just note that in order to install this SAM, you need to have Docker first, and I'll have a link in the description that has more info on how to get going on that. So the first thing that we're gonna do is we're actually gonna run AWS configure, and AWS configure is gonna ask us for our access key, so we can copy paste. It's going to access for our we'll access for our key ID, and then this is our access key secrets. We're going to do copy paste, and then it's also going to ask us for our default region name. We're going to call it we're going to use this US East 1. Default output format should be JSON. And note here that we have this AWS Explorer. This is a browser extension that I installed because it recommended. I'm actually going to uninstall this. For the way that we're going to do it, we actually don't need this extension, but you could do the same thing that we're doing through this AWS Toolkit extension too. I just prefer to do it through the command line, but I will uninstall it now to prevent any confusion. So now that we have AWS configured, we're going to want to get the template for the Lambda, and the way that we're going to do that is with this sam init command. And it's going to prompt us. We're going to want to do the AWS Quick Start template. And yeah, let's just do this hello world example. Use most popular runtime and package type, Python and zip. Actually, we're not going to do that. We're going to use Node.js 18. So we're going to use 11. And let's just, we'll keep it with the zip. Select your starter template. Yeah, let's do TypeScript for TypeScript. X-ray tracing, no by default. Enable monitoring using CloudWatch application. We're just gonna use the suggested defaults there. What are we gonna call it? We're gonna call it the SWE. We're gonna call it SWE place indexer. And we're gonna wait. We're gonna be back when it finishes cloning. So note now that we have this new folder, this SWE place index folder in our repo, and this gives us 2 additional folders: this event and Hello World. Hello World is where all the actual code in our test is going to be for the Lambda, and events is going to be this is just a utility for testing. So we're going to switch our focus to this app.ts. So this is where the Lambda is actually defined, where the code for the Lambda is defined. So now we're going to turn our attention to this app.ts in Hello World. This is where the actual code is going to get run. We also have a testing folder here as well, but this file, this app.ts, is where the actual magic is going to happen. So the way that this Lambda handler is going to work is this event. It's a function that takes in this event, which is it has more information about it, about the request that was made. So like from what IP, like what were the query parameters, right, etc., stuff like that. What were the request headers, and then we're going to return an object that has like the status code. What do we want to return? And then this is like the body for what's actually going to go in it. And this is going to be, for us, this is going to be a JSON string. And the way that you can think about lambdas is that this function represents a web server. So we don't have to worry about creating a web server. We don't have to worry about exposing any ports. We don't have to worry about installing Ubuntu. We don't have to worry about any of that. All we have to do is write functions that take in what are the requests and what are the responses, and then we can integrate that with the AWS cloud, and everything will work great. It'll be a lot easier than if we tried to implement all this ourselves. And now I notice that we're getting this error where it says it can't find the module AWS Lambda, so we're going to go to cd SWE place indexer to get back to our index folder, and then we're going to go into this hello world. This hello world acts as it's like its own npm repository, so we have to do npm install, and then it's going to install all the dependencies that are in the template already previously defined from this dev dependencies and dependencies. And now that we have everything installed, that error message goes away. And then we should be able to see everything that event gives us. It should integrate. Oops, it should integrate. Yeah, so we can see the body of the request, the headers, the HTTP method, path, etc., all that kind of stuff. And so let's make sure that this is working. So let's just change this to be something like hello SWE. So now that we have this hello SWE message, let's go ahead and get this built and deployed to the AWS cloud. The way that we're going to do that is we're going to run 2 commands. The first is sam build, and that's going to, you want to make sure to do that whenever you're, because we're doing TypeScript. If you're using JavaScript or maybe Python, I don't believe you need to do sam build first. But with this specific setup, we're going to do sam build. Next we're going to do is sam deploy guided. And that's going to give us a bunch of prompts, and let me make this a little bit easier to read. So default stack name, that looks fine. Region looks fine. Confirm changes. Yep. Just hit enter. Hit enter. We're actually going to say, is this okay that it has no authentication? Yes, because that makes sense for us. Save arguments. Yes. Yes. And then it's going to run. And this might take a little bit. It might take 3, 4, 5 minutes. Don't worry about it. It will eventually complete. And when it says deploy this chain set, make sure to press yes. And once it completes, we should have this endpoint URL, and we can open that in Chrome. And yeah, there we go. We just have this message, hello SWE. And the way that it gets it, again, is by calling this function and returning this and interpreting this as a response body. So now what we need to do is we need to integrate this, and we need to set the functionality here of what it actually should be, right? And that's we're going to make the RPC call to get all the pixels, and then we're just going to return all those pixels. So the way that we're going to do that is we need to go all the way back to our front end and modify this. We need to modify this deploy script. But right away before we do that, we're going to go back to our root, and we're going to just add everything to Git again, because it's good practice to have things committed to Git. So initialized Lambda indexer. And now what we're going to do is we're going to go back to the deploy script. Don't worry if you get errors. It's because we have, like, this is node and this is not node, so we're just going to run into problems with that, and that'll go away, or at least it won't matter. And we're just going to make a very small change. We're going to, right now, we're writing this to this source deployed objects.json. But what we actually want to do is, now what we want to do is we need to not only write it to here, but we also wanted to put it in this source. And specifically, we want to put it in hello world. We want to put it in, just the same folder as the app.ts. And so what we're going to do is we're going to copy paste that. We're going to do index path. So we have path to scripts. So again, at this point, we're right here. So we want to go back one, then we want to go back another one. So // and then we want to go, we want to go into sweep place indexer, and then we're going to want to go into hello world. And actually, let's change the name of this, just as an example of how to change configs. So we're going to name this to let's say get place board. Update imports, sure. And then we want to, in the package.json, rename this to get place board. Then we want to edit this template.yaml. So, and then we want to change this code URI. We're going to change this to get place board, and also change this to get place board. Great. And then we're going to deploy this again. We're going to do, let's go back to CD, back to sweep place indexer, and then sam deploy. While we're waiting for that, notice that we didn't do guided, and if we don't do guided, it's going to just do the same. It's going to do the same deploy and with the same settings as we did last time. It looks like it says no changes to deploy, probably because we have to build again. So sam build, and then sam deploy, and then we deploy the chain set. Great, go back to our deploy.ts. So now that instead of hello world, we're going to put it in sweep place indexer / deployed objects.json. I'm going to make this a little bit easier to read. And I'm also going to, again, that's just the path. We need to actually write the file to that path, so we're going to do index path. So now it's putting in both places. And again, apologies for trying to do two things at once. I just get a little bit excited. I'm not the kind of person that likes waiting around for things to deploy. But note that now that when we go here, instead of it being at hello, it's going to be at this, or what do we call it? Yeah, get place board. And there's the message. And if we go back to hello, note that it's not working anymore. So perfect. That's what we want to see. And now we can go back to the front end directory and we can do npm run deploy. And then that will get us, as soon as this finishes, this is going to put the deployed objects in this folder. I just noticed that I mistyped the path. Again, well, maybe that's a reason why I shouldn't be, doing two things at once, but oh well. So yeah, again, get place board instead. There, and now that we can see deployed objects.json is built in both, both here and here are going to be exactly the same file. And now let's get this JSON file able to be imported in our Lambda in the same kind of way that we did it in the previous project, or with the deploy script. And recall that in this tsconfig.json, there's this option that we have to do. If I recall correctly, it's like resolve JSON module, and this has to be set to true. And Yeah, so let's import it. Do import quadrants from deploy.json, and we're going to do, let's just return the quadrants as the message. So we do like quadrants, quadrants. So and then and then let's sam build and then sam deploy again. Sam deploy. This double ampersand, this is a whoops, wrong folder. This indexer. What this double ampersand does is it runs this first command, and then it's going to wait until that command finishes, and then it will run the second command. So you just don't have to type it in one after the other. It's just a little bit quicker. And once we refresh this get place board, you can see that yes, in fact, the Lambda function can see that JSON object. So now what we want to do is we want to install the Mistin Sui.js package so we can actually make the RPC calls that we want to make. And we're going to do that by going into get place board, and recall that these are all separate npm modules. So we need to do npm install mistin/sui.js, and we're going to import it here. We're going to do import. It's just going to be the Sui client. So we import Sui client from mistin sui.js/client. And then at the start of this Lambda, we're going to create this client. So new const client equals new Sui client. And here's where we have to put in the full node URL. And so here's like recall that the whole point of doing this is because we're trying to hide this particular URL from the public view, right? This is supposed to be a private URL. If we're just going to use public, right, why are we even doing the Lambda in the first place? Might as well just encode it in the front end. So ideally this is going to be like the Shinami URL or whatever URL like that points to a full node that you're paying for. At the moment, I'm not paying for any full nodes, so we're just going to demo this by using the regular public, public DevNet full node instead. But also if you're actually doing this in a real project, you probably don't want to hard code this URL. You probably want to put it in like either a .environment file or like AWS also has other ways of doing credentials. Because again, you don't want to have that URL be committed to source. Because if you later decide to open source your project, then everybody is going to see, that sensitive URL. Then they can steal it in the same kind of way that, for the same reason that we would want to hide this URL behind a Lambda, we'd probably want to hide that URL from source too. But for now, I'll just replace this with the source. And actually, I don't even need to recall because I know that at the moment, we have this. We got full node URL also from the client, and we're just going to do devnet, which is the same thing we're doing elsewhere. So now that we have the client, again, we have these 4 quadrants. So we're going to do the response that we care about. We're going to do responses. So quadrants is a array of strings, and then we're going to do map quadrant ID. And then with each quadrant ID, we want to use the client to get object, and we're going to put the ID of quadrant ID, and we're also going to give it some options. We do want it to show content. It's going to be true. And then at the moment it says that this is going to be an array of promises. However, what we really want is one promise, or we really just want the array of collected responses. And we're going to use something in JavaScript, a utility called promise.all. And so what this does is it creates an array of promises, and it takes an array of promises and it returns if after a wait, it's just going to return the list of responses to each of those promises. And then this is what we're actually going to want to return. So replace this with responses. And we're pretty close to done actually, but we're not going to do that quite yet, and that's because we probably want to handle error handling. So if one of the things with this async await syntax is that if one of these promises rejects, or if there's an error somehow in this RPC call, we're going to get a regular. This is going to transform it into a regular like JavaScript error, right? That we can just throw, and that works directly with try catch. And so we're just going to do, we're just going to return like an error code 500, and with some message if there was a. And I'm actually going to change this to internal server error. And we're also going to log this to the console. If you ever want to see these console logs, or if there's any kind of error, another really useful tool is samlog. And that's going to show you what are the most recent logs that showed up in one of these lambdas. So now that we have that, and let me just double check. Yeah, this all looks good. Another thing that we're going to want to do is we're going to want to add some headers. So we're going to want to do headers. We're going to do content type application / JSON. And that's going to let the browser know that this is that we want to make sure that it interprets this as a JSON object. So now that works, let's run this sam build and then sam deploy again, and we will come back when this is finished. And keep forgetting again, you have to be in this directory. And so now when we come back to this URL, this is going to be an array of all of the responses for that, which is exactly what we wanted. And again, it's just going to be this big, huge list of white, because we redeployed it, it's all going to be white. So this is exactly what we wanted. Everything was good, and that's pretty much the Lambda finished. I don't believe that we're going to have to make any more significant changes to this. So let's just git commit this, and then we can move on to integrating this back with the front end. So at the moment, you can see that this is the result of our get object sync hook, and again, it's still just going to the RPC and trying to do this SWE get object with each of the four RPC IDs, and that's not what we want anymore. So the way we're going to fix that is we're going to go back into source components utils hooks. And we're actually going to change this, and we're no longer going to require this wallet, so we don't care about this code anymore. And we're also going to delete this ethos dependency, because we don't need anything to do with ethos. And then, going back, we can replace all the wallet code with this, and the RPC code with this fetch. So just the basic, this is built into JavaScript, so it fetches the URL, and then it parses it as a JSON, and then puts that parsed JSON into our set object. And we're going to double check this to see that it works. At the moment, again, recall that we're calling this 4 times, so we have this map. And we're gonna want to get rid of this code too, because it's not really what we want. What we really want is to go back to this, the simplified quadrant responses equals use object sync, and we can get rid of this object ID too, and we're not using it, and all we need to do is pass in the interval. So let's stick with every 5 seconds. So delete this because we don't need it anymore. It says this is a SWE object data, so let's go ahead and change the types. If we're actually going to, we want it to be the same thing as so we're actually gonna, instead of doing it as only SWE object data, we're gonna do SWE object data, or it could be null, and we're just gonna have the null be, it hasn't gotten any data from the server yet. and then that null is going to represent the loading state. So actually another thing we can do is if this catches, then we're going to want to set a loading set object back to be null. And what this is what this is doing is that if we find an error anywhere, we're just going to say that, hey, null is the error state, and we're going to go back to the error state. And again, when we're using this async await syntax, when we're just using like the .then syntax for promises and like chaining with .then like that, we can use .catch. But when we're doing it with try catch statements, catch e and set object null. Then if we're doing it with the async await, we need to do try catch syntax. And it's also good practice to console.error there. Great, so let's go back here. It says, again, the reason why we're doing this code before is because each of these could fail individually, but now they either fail all at once or not at all. So instead of doing that .every, we can just go back to doing this. So if quadrant responses, and actually we want it to be if not quadrant responses. So if it's null, we want this to come back as loading. And then this code from here on out, this code is going to be the same. And we can actually get rid of this, so we don't need it anymore. So now if we go back to our front end, we can see that instead of making a bunch of, it still makes a bunch of full node queries, but this is because, this is because we're, this is done by the wallet, not by us. But what we're doing is this get place board, all these get place board requests, and these are not working because of something called cores. And what cores is it's a way of protecting, it's a way of protecting sites against something called cross-site scripting, which we're not going to get into. But the way that we fix this is we need to set a certain header that I forgot to set on our Lambda. So we're going to go ahead and do that now. And what we need to set is, I'm just gonna copy paste this. Otherwise, I know I'm gonna misspell it on accident or something. So, app.ts, and it's gonna be. We're gonna need to set access control allow origin to this asterisk, which means all. And then again, since we're in our indexer, we can run this sam build deploy script again. And now when we run this, we get a few errors. It says that we cannot read properties of undefined. And after looking back and just doing a little bit of debugging with console log of what we got versus what we had before, I'm pretty sure what's going on is before we were correctly handling the fact that it was inside this data object, like the content was inside data. So I believe a simple fix is just going to be response.data.content and response.data.digest. And it would appear to all be working. So let's just double check. Put black in the middle somewhere, hit approve, and wait and see how long it takes to refresh. And there we go. Now what we have to do is we have to get rid of the code that requires the wallet. And the way that we're going to do that is recall back in this app.tsx. Now it actually doesn't matter what status we are. We don't need to we don't need to say loading wallet or sign in button if you're not signed in. What we can do is get rid of all this. And so now that we have that removed, in the case that the user does not have a wallet signed in, we probably still want to show them a sign in button. So what we're going to do is we're going to have this compact picker, and instead of, so let's say that we'll check the status. If the status is equal to ethos connect status dot connected, then we're going to load then we're going to load the compact picker. Otherwise, we're going to show a sign in button that says sign in. And since we do have our wallet installed, let's manage this, turn it off temporarily, see how this responds. And so it's going to do sign in. And there you have it. So from the position of this Chrome browser, I have my Sui wallet completely disabled. So it has no clue what RPC I'm using internally. So it's just using this. Anybody without a wallet installed can go in and they'll see, this place board. It's only then if they want to, and we'll change this later to make this look a little bit prettier, but the functionality is there at least. So if they don't have a wallet, they're prompted to either install a wallet, or if we go back to having this enabled and we refresh, then it will now show up, and then we can go back to to placing pixels. And once again, recall that when we're not signed in, it will not, when we control click this board and we're not signed in, this code is still going to run, but we're going to get to this wallet.sign and execute transaction block. However, again, is because this operator only calls this function if this wallet is defined. And if we don't have a wallet, it's going to be undefined, so we're never signing and execute, right? So we never run into any kind of error there. And that's the project. And yeah, I would say that Sui Place is in a lot better spot than it was before. We can now place pixels. We can we can still place pixels. We can not have a wallet and still view all the kinds of creations. You could also, of course, play around with the AWS Lambda, and you definitely want to make it more secure. One advantage of Lambda is that you can add your own caching and rate limiting situations. So at the moment, this is a really good candidate for having a caching strategy, right? We have a ton of data that we need to download, and we know that it doesn't change very often, right? Because somebody might only place a pixel every or 10 seconds. Realistically for us, right, this isn't a big project, so someone might come along and place a pixel every few weeks. So we definitely want to have a caching strategy to save on costs. At the moment, with low users, it probably doesn't matter too much because the free tier is pretty generous. But if this were to scale up, we definitely want to have a caching strategy. And with AWS Lambda, the one way you can implement that is with these WAF Lambda rules. And I'm not going to go into in depth on how to do that, but I would recommend definitely taking a look on that and how to do rate limiting versus caching and stuff like that. So thanks for sticking around for the index tutorial. I hope that you learned a lot. We didn't make a fully fledged indexer, but I would say that what we have so far, this Lambda function is could be described as an indexer definitely, and leads you certainly in the right direction to what you need to do. So thank you so much for watching, and I'll see you in the next tutorial where we will be going over how to integrate the Shinami gas station with Sui Place so that we can make it so you don't even need gas to use this application. Thanks for watching.